Let's dive into a little bit of the reinforcement requirements. There are a few things to be aware of when looking at the reinforcement needed. Dead loads, live loads, the self-weight of the system, which includes the thickness of the slab, concrete joists, and the span. As we just mentioned a few slides ago, having a single or a double span will have an impact on the Amdeck reinforcement. The final design will be project specific and approved by an engineer who designed it. As I already mentioned, we do provide design guides for both the Pro and the Eco versions, and they're available on our website under the Techno Resources tab. The guides are a good starting point to check your span and see what rebar may be needed. This would be a good starting point for estimating and preliminary drawings. However, once a project reaches a more mature stage in the design, the structural engineer would review the proposed reinforcement and either approve it or make adjustments based on the site requirements. Although Amdeck might look complicated or intimidating at first, it is essentially a one-way slab. A one-way slab is very similar to a wood joist system where the load will transfer to the joist, which will carry the load then to the wall or a beam. This is exactly the same here, with the main differences being the joists are concrete with different spacing. For comparison, a two-way slab is where the point load would transfer its load in both directions, as opposed to the single direction of the one-way slab. A two-way slab would need to have support on all four sides, beams or walls, while a one-way slab requires supports only on two of the sides perpendicular to the joists. The same goes for concrete joists. Although their cross-section is not a simple rectangle, when designing their reinforcement, their more complex cross-section is simplified to what you see on the right-hand side. This is basically a slab and a rectangular beam. This allows the designer to calculate things like shear strength, moment strength, positive or negative, short or long-term deflection, etc. The more complex joist cross-section would only play a role in determining the self-weight of the system and the rebar placement in terms of minimal concrete coverage. This is an example of what minimal versus significant reinforcement looks like. On the left, this type of reinforcement configuration could be used to span around 20 feet for typical floors in a house where you have bedrooms, bathrooms, kitchens, etc. On the right, you have a very substantial reinforcement that might be used for spans around 23 feet with two cars parked on top of it. Your typical double garage width is around 20 by 20. The key takeaway here is that you use the same Amdeck system with the same slab and the wood joists, but the reinforcement changes how and what configuration can be used. The Amdeck system, like any concrete slab, would need to be tied back to the wall. This is easily done by bending the ends of the rebar either up or down into the concrete core. When your slab portion has rebar, the bent dowels would match the spacing of the rebar. When using welded wire mesh, one would need bent L-shaped pieces of rebar to be placed along the perimeter of the Amdeck at intervals as specified by the engineer. There are multiple ways of connecting Amdeck to the wall, and each engineer will specify if they want all the rebar to be straight and then added L-shaped dowels, or whether they want spliced ends, or have the ends bent and by how much. The most important thing to remember is to make sure that you have rebar connecting the slab to the concrete wall core. The foam portion of Amdeck acts as a platform to work on and formwork to hold the rebar and the concrete. The wood or metal joists are designed to support temporary construction loads. The joists typically rest on the concrete, requiring minimum 4 inches of bearing. For the metal joists, we recommend screwing them down using the concrete screws. Since the wood joists could be non-treated lumber, the ends need to be protected from the direct contact of the concrete. The wood ends can be wrapped in 6mm poly, or self-adhesive waterproofing membrane, or self-adhesive flashing membrane, something that is water and vapor proof to make sure it doesn't rot over time. If you have attended our ICF training, you might have seen a similar slide to this one already. The principle of rebar splicing is the same. Two pieces of rebar should overlap by 40 times the diameter of the rebar. In using non-contact splice, you're limited to a maximum of 6 inches between the two pieces of rebar.